Hi, so we're group 19 and we're going to be talking about wind power as an alternative energy choice with respect to fossil fuels. So first, I'll briefly introduce the context in which our discussion is taking place before discussing the impacts of wind power with respect to land use, and then we'll discuss CO2 emissions associated with this type of energy generation before discussing its feasibility in Australia, and finally doing a short conclusion. So where are we now? So in 2022, energy-related CO2 emissions reached a new high of over 36.8 gigatons. So the energy supply sector accounts for around 35% of global greenhouse gas emissions. And in Australia specifically, which has CO2 emissions per capita almost double the OECD average, 58% of electricity generation is coal-fired. So it's within this critical context that we propose wind power as a viable alternative energy choice to fossil fuels. So what are the land use requirements of wind energy? So let's first talk about offshore wind. While offshore wind does not compete with other land use activities, it does affect biodiversity. However, these impacts are not yet entirely understood. Negative impacts, for example, include the effects of noise on biodiversity, while positive impacts include, for example, the artificial reef effects, which provide habitat to various species. Then when it comes to onshore wind, the land use that's necessary to produce energy through onshore wind is highly variable depending on how the land use area is actually calculated, as can be seen on the figure to the left. When land use includes the total area that makes up a wind farm, then it ranks highly in terms of land use associated with energy production. However, if we discount the spacing between the wind turbines, so only accounting for the area which is occupied by the actual infrastructure, then wind power becomes highly land use efficient, even becoming one of the most land use efficient forms of renewable energy. And so why does it make sense to discount or omit the unconstructed areas of wind farms to get this smaller footprint? Well, firstly, because the wind turbines themselves only account for 1 to 10% of the dedicated wind farm area. But also, wind power can be located on sloped terrain or low quality land, such as brownfields, thus eliminating the problem of competing uses. More importantly, though, these areas can be used for other purposes at the same time. So, for example, grazing, agriculture, and recreation all constitute activities which can be undertaken on the same land where wind power generation is taking place. Solar PVs can also be installed on the same land as wind turbines, and with minimal loss of solar power due to the shade of the wind turbines. And so all of these combined uses reduce the land use footprint of wind power. And by combining these practices within the wind farms, wind power has the potential to be highly land use efficient.
And I will talk about wind energy regarding CO2 emissions. The major reason that wind energy is greener than the fossil fuels is that wind power plants has no significant greenhouse gas emissions when converting the kinetic energy of the wind into the electricity. However, there will be indirect emissions produced during other life cycle stages. To determine the carbon footprint, the researchers conduct a life cycle assessment of the energy sources, which analyzes the emission through their lifespan. From this chart, compared to the fossil fuels like coal, we can clearly see that the coal is 77 times greater than the wind energy, which produce 1,001 grams of CO2 equivalent per kilowatt hour, and wind energy only produce 13 grams, which is the lowest emission among the other energy sources. The majority of CO2 emissions of wind energy is in the upstream process, which includes the emissions resulting from raw material extraction, manufacturing, transportation, and construction, which is about 90% of total emission in their life cycles. Others are from the maintenance, decommissioning, and recycling of wind turbines. However, these emissions are relatively low compared to the fossil fuels, which is shown on these two charts. The emissions of coal energy incurs mostly in operation and maintenance process, which are way more greater than the wind energy. And the wind energy is mainly divided into onshore and offshore wind turbines. By their own characteristics, the results of life cycle assessments show that Offshore wind turbines have greater life cycle emissions than onshore due to the floating platform fixed in the sea. Decarbonizing the grid is one of the steps to reduce carbon emissions, which follows the Paris Agreement. To achieve the goal of carbon neutrality, regarding the wind energy 20 years lifespan, more efficient equipment production and innovative materials may decrease the CO2 emissions and energy demand. In the recycling process, 85% of expired wind turbine materials has already been recycled. The large wind turbines manufacturers are aimed to getting to 100%. The Siemens Gamesa claimed to be the world's first 100% recyclable blade, and Vestas is also on track to getting there in 2030.
As with most renewable energy sources, wind energy is associated with meteorological variables, reviewing Australia's living climatic and geographic conditions to determine the wind power availability is possible. Generally, winds are weak near the equator and on the polar surface, and westerly winds are located at the surface latitudes of 30 to 60 degrees in the central hemisphere, whereas Australia's national extent is located between 10 to 50 south latitudes within the westerly wind belt. Also, some studies mention the interference of wind by a house, forest, or hills. Fortunately, Australia has extensive plains with a straight coastline that can reduce the impact of turbulence on wind power stations. Some studies have explored the price of zero-carbon energy versus living fossil energy source, finding that the average cost of electricity is estimated to be $70 to $99 per megawatt-hour, a price comparable to the cost of current and future fossil energy systems. The Australian Renewable Energy Agency has announced several living wind projects that validate the feasibility of wind projects for Australia. As technology advances, more wind energy projects will be implemented. In summary, we have reviewed the area covered by the wind power station and found that the turbine only takes up a small portion of the entire site, and spare land can be used for other purposes. Meanwhile, it can use rocky land such as sloping area. Secondly, CO2 emissions from wind energy occur mainly in the upstream supply chain. Wind energy produces only a few CO2 emissions compared to conventional fossil energy. As technology develops, wind power stations can use more environmentally friendly materials to minimize environmental impact further. Finally, Australia has a lot of areas suitable for wind energy. There is not a lot of obstruction, and wind energy is inexpensive. This evidence suggests that wind energy is an appropriate alternative energy source for Australia. Thank you for listening. And there's the reference we used for the presentation.